polyatomic ions. So here we have one or more elements combined with oxygen, is what most of them are. The ones with oxygen are called Oxy Anions. They're anions that have oxygen in them and something else. So for the Oxy Anions, most of them end with the suffix ate, but some end with the suffix ite. And that's one letter different, but it's important. There's a couple of odd ones, cyanide and hydroxide. We need to know these because they're quite common. They have the suffix "ide," kind of like those nonmetal monatomic ions, but these are polyatomic. And then there's only one polyatomic cation that you need to know, and that's ammonium. Ammonium. So I think there's a table coming up. There it is. See what this says up here? Memorize these ions. What do you think that means? You need to memorize these ions, right? Is that clear?
Yes.
Which ions are you supposed to memorize? These ions, okay? The slides are on Blackboard. I got them up late, but they're there. And so you can go and see this slide, and it says, memorize these ions. This is table 6.3 in your textbook. So you also have a copy of it there. So there's one cation, NH4+, and its name is ammonium. This is where some index cards and a pencil would be really helpful. I'll make some flashcards. Stick them in your pocket or in your glove box, and when you're stuck waiting for the train over there, pull them out and flip through them, right? Or if you're trying to go to sleep at night and your mind is racing, pull them out. They'll put you right to sleep, right? It's awesome. And then most of them are anions. So there's acetate and carbonate and chlorate and chlorite and chromate. Here's cyanide. This one is a little different. It's got a different ending. There's dichromate, hydrogen carbonate, blah, blah, blah. And then this one's a little odd too, hydroxide. So those two that end in I, the rest of them end in ate or ite. And all of them there, except cyanide, have oxygen in them. And of course, ammonium. Okay, so there are some tricks to this. Mrs. K's tricks. Memorize the eights. What do I mean by the eights? Well, the ones that end in ate. So memorize acetate, carbonate, chlorate. I'll show you a pattern for this one. There's another 8. Now, sadly, most of them are 8s, but still. So memorize the 8s and the pattern I'm going to show you. Here is a family of oxy anions involving chlorine. This is the one you memorize, chlorate. That's like your basic version. And then this is chlorite. What's the difference between Bud and Bud Light? A third fewer calories, right? Isn't it amazing how those commercials work? I don't even drink beer. It smells bad. Why would I even taste it? Chlorite is the light version of chlorate. The only thing that changes within this family of ions is the number of oxygens. The charge stays the same. The number of chlorines stays the same. So from this one to this one, it's just one less oxygen. And then there's another one that has one less oxygen than the light version. And so here we're going to put a prefix on here. The prefix hypo means below. Where does a hypodermic needle go? Under the skin, your dermis, below the dermis. Hypochlorite, one less oxygen than the light version. So this is ClO, still with the -1 charge. What if you have an extra oxygen? A child that is hyperactive, are they more active or less active than a regular child? They're more, right? So per is like the ending of hyper. It's more. Perchlorate has one more oxygen. The charge is the same. See the pattern there? So if I memorize the name and formula for chlorate, I can figure these others out in reference to that one. And then, bonus, bromine and iodine, I told you those are chlorine sisters. They're in the same family, follow the same pattern. So by learning just the chlorate and the pattern, you can actually do formulas and names for 12 oxy anions. So what would the formula for bromite be? BrO2, and what would the charge be? Minus. It's just like chlorite, except you put Br in there instead of Cl. How about periodate? Oops. Spelled that wrong. That's really bad. Wait, there's no periodate. That's not a C. Periodate, just like perchlorate, IO4 minus. Okay? Provide a systematic name for each of the following polyatomic oxy anions. Now this is going to be a little challenging because you haven't memorized these things yet. It's great to memorize things and know everything. But sometimes you just have to make kind of an educated guess. So let's make some educated guesses. NO3 minus. Nitrate. So your best guesses there would be nitrate or nitrite, right? So nitrate is correct. So nitrate ion. And how do you know that? You memorize it. There's not really any great way to figure those out. I'm sorry. OH minus. That's hydroxide. Hydroxide is a very common one, and so that's really important. Hydroxide. What about that guy? That one's acetate. Why is it acetate? That's a trick question. Why is my youngest child named Andrew? Because we named him that. Why is this acetate? Because that's what we decided to call it. HSO4. So I'm getting some interesting answers here. Hydrosulfurous, that's a good attempt. Well, that H is kind of problematic, isn't it? Let's cover up the H. What do you think that is? Or similar to? Sulfate. Sulfate, and there's a hydrogen in front of it. Hydrogen sulfate ion. These guys have two names. It's hydrogen sulfate. It's also sometimes called bisulfate. I don't know where that came from, but that prefix bi means there's a hydrogen on it. I don't know. Yes?
But since there's an H in the beginning, isn't it an acid also?
Good question. Isn't it an acid because it starts with H? It would be an acid if it didn't have a charge on it and it was dissolved in water. There is something called sulfurous acid, and we'll learn about these. Sulfurous acid is H2SO3 aqueous, and sulfuric acid is very similar to this hydrogen sulfate ion, H2SO4 aqueous. But these acids don't have charges. So if it's got a charge on it, it's an ion. It's a very good question. Any other questions? Give the formula for these guys. Starting off with a tough one. Dichromate. Yeah, it is going to be Cr2.
Would it be a bromine and bromine?
Well, this is, these are polyatomic Oxy Anions. So it's got to have oxygen. And it's got to be an anion.
O3?
Be a good guess. It's actually O7. What? Sorry. This is a weird one. And honestly, chromate and dichromate are not that important. This one's chromate, and that one's dichromate. And it's like almost two chromates, but not quite. Sorry, that's a weird one. That's a weird one. Probably shouldn't start with that one. Bromate. BrO3 with a -1 charge. Phosphate. PO3 is a good guess. It's PO4. It's like, guess my favorite number. It's PO4 3 minus. There is one pattern in the periodic table. Chloride, bromide, iodide ions have what charge? -1. Bromate has a -1 charge. Phosphate has a -3 charge. Phosphorus by itself is an ion. Phosphide also has a -3 charge. And sulfate has a -2 charge. Sulfide has a -2 charge. That can help you. Doesn't really help you with the 3s and the 4s with the oxygens. There's some of this stuff that you just have to memorize. Sorry. I should look at this in my spare time. I'm wondering if someone has made an app for quizzing yourself on these. I don't know. Maybe somebody could do that and make some money. Probably wouldn't have real big appeal to the general public. Hydrogen carbonate ion. Well, the hydrogen is telling us H. Carbonate. So it's got to have some carbon in there. And the 8 or ite means it's an oxy anion, and so it's going to have an O. And with most of the 8s, it's either a 3 or a 2. So this one's a 3. So I'm going to get rid of the H for a minute. Carbonate is CO3 2 minus. When we make it into hydrogen carbonate, we're adding a hydrogen ion, an H plus. So here we have a +1 and we have a -2, and those are going to add up to -1. So when I put these guys together, hydrogen carbonate is HCO3 -1. That's also called bicarbonate. So at home, you probably have a little yellow box of baking soda. It's sodium bicarbonate. You've got that in your kitchen. Not everything's horribly toxic. Any questions?